This video is going to show you how to write balanced nuclear equations from the National 5 Chemistry course. Now, before we can go into balancing these equations, we have to do a wee recap on your nuclide notation from Unit 1. So let's say, for example, that you were asked to write the nuclide notation for americium 241. Americium is the element, so from the data book you can find the element symbol. If you look up americium, it is AM. 241 is your mass number, which you would have to be told because that can vary. The mass number goes up the top. And for nuclide notation, you also need an atomic number, which does not change for the element, so you will find that in the data book. For americium, it is 95. So just to confirm, the top number is the mass number. The bottom number is your atomic number. And that is important to be aware what way round it goes to begin writing these equations out. So keep this wee part in mind. This might look quite different compared to what you've seen before, but you should definitely be comfortable with the nuclide notations. So going into writing your equations, there's two different types that you tend to get, and it is the alpha decay or the beta decay. Now, decay means it will release something. Alpha, you should know from the previous section, is one of the types of radiation. You may have seen this symbol before, but it's also written as a helium atom, 42He. This part is going to be important for the alpha decay nuclear equations. This bit might make it difficult to complete, but would still be included. So essentially in alpha decay, your reaction or equation is showing an alpha particle, so 42He, being released from a radioisotope or any substance. So that should be shown on the right hand side of your equation in the arrow. So if we take an example, we go with the alpha decay of americium 241, just like we've used. Now that means you will start as americium 241. So as we saw a wee minute ago, we need our symbol for americium. 241 is the mass number up the top, and the atomic number is from the data book. I find it best to use page 4 of the data book, so this one here. Just they're laid out the best way for finding the element symbol and the atomic number, but whatever page works for you. So alpha decay, I then want an arrow. I then want an alpha particle, 42He. Now, something will be missing because when this radioisotope breaks down, it will release radiation, and this particular one, it's releasing it in the form of alpha. It will also release something else or produce something else because it's broken down into things. So radiation plus another radioisotope potentially. So there's something missing here. So sometimes the question begins from the first line, where you could be writing an equation for the alpha decay, or it could have been started for you and there is something missing. So it just depends how challenging it is. So to figure out what's missing, this is just a little bit of simple numeracy and using your data book, so it should be quite easy to pick up marks. So you need a nuclide notation, meaning you need a top number, a bottom number and a symbol, just like you have for all of these. So all three is needed, otherwise it's incomplete. Now the main tips to follow are is that on both sides, the bottom number has to be equal to each other. So equal bottom numbers, or atomic numbers if you want to remember it that way. And you also need equal top numbers or mass numbers. Bottom and top don't need to equal each other, but on each side the top equals and the bottom equals each other. So you'll see from the completed answer in a wee second. So in this case, if we take the bottom numbers first, you'll see on the left it's 95, on the right it's 2. I need those numbers to be equal, so I can't just change this, I have to add to that side. So to get 95 on this side, I need to add 93. So I've now got 2 plus 93 gives me 95. Bottom number's done. The top number, you again do the same thing. So it has 241 on the left and 4 on the right. So I need 237 to make 241. To get the symbol, you want to take your bottom number, which is your atomic number, use your data book to find the element and write its symbol down, and you will see it is neptunium, which is Np. There is your final answer for this question. So now what we're going to do is take a different example and have a look at beta decay. So we've looked at beta before. We know the symbol is either this, the capital B with the little kind of tail, or we also know it to be an electron. So the 0 up the top, -1 down the bottom. You can remember what way round those numbers are by the fact that -1 is a lower number than 0, so it will go down the bottom. Again, I would be using the one with the values in it for the equation, so we're going to use the electron symbol. So we will look at the beta decay of carbon 14. Exact same rules, but you've got a different symbol now. So carbon 14 is capital C, 14 up the top, and the atomic number is 6. Beta decay, I've got a 0 minus 1e and the missing value. So you have your bottom numbers, 6 on the left, -1 on the right. So to make them both equal, you are going to want to increase the right hand side, and you're increasing it by 7. So 7 plus -1 gives you 6. The top number, this one's quite easy. It's 14 on the left, 0 there, so you need 14. Again, use your data book. Nitrogen is atomic number 7. So just take care of that final bit, finding the correct symbol. And that's your final answer there. Now, final one is just a wee bit of a challenging question that has come up a few times. So let's say you were given this equation and you were asked to complete it. So you'll see it looks nothing like what we've just did. It's not alpha or beta decay, but it's a similar concept. So if you were asked to fill in the missing value or isotope here, what we would do is the same rules. So both sides equal bottom number and equal top number. So the bottom number is 95 and 2 on the left. So actually that's 97 in total. On the right we have 0. So we need to put 97 here. So it might even be worth making a wee note to yourself. That bottom number has to be 97 on both sides, just to help you out. Top number, 241 add 4 is 245. So both sides need to be that. So to add to the right hand side, we've already got 1 up the top So we need 244 being added. So a bit trickier, a couple more steps, but same concept. So final part is looking it up and finding your element. So we're looking at capital B, small k is your missing answer there.